song. Never tell a fact that I never stay running. Sipping on facts, damn, know I got stacks in the lab. Taking bitches straight for another cat. I ain't shit one, I never had shit. Bitch, move, make your motherfucking head split. Hospitalized, never break. Hello guys, so today's video is a very special video wherein we are going to try to solve a problem which recently appeared in TikTok coding OA, or we can say online coding test of TikTok for software engineer role. So this problem was very much interesting, and let's discuss this problem. Okay, at my place it's midnight right now, but recording this the solution to this problem is very much important for my students, or else how will they become successful, right? My mentoring students. And if any one of you watching this video want to enroll in my mentoring program for DSA and Dev, they can check in the description. So guys, let's get back to business. So the thing is that we are given an integer array nums. Okay, nice. We have to handle multiple queries of the following two types. Okay, given a value x, update all elements inside nums that are less than x to x. Okay, given an index I and a value v, modify nums of I to v. Okay, and if we see the length of n is from the maximum length of n can be maximum 10 raised to 6, and the number of queries m will be maximum 10 raised to 6. So let's discuss it with a small example. Say we are given this array 2 3 4 5 6 7 8 1, and now a query comes up which says that what was the query? The query say, okay, the query number 1 comes and we are given an x value. Then we have to change all the numbers which are less than x and we have to make it equal to x. So let's say for this array, the first query is of type 1 and the number x is, let's say x is 5. If x is 5, it simply means that whichever numbers in the array which are less than 5, you have to turn those numbers equal to 5. So what will the updated array look like? We have to return the final updated array. So we had 2 3 4 and 5. So 2 3 4 are all less than 5. So I'll update 2 2 also 5, 3 also 5, this also 5. Then okay, 5 will remain 5, 6 7 8 1. Okay, 5 will remain 5, 6 7 8 1. We cannot do anything because these numbers are greater than 5, so we will not change them. And there is 1, but we cannot write 1 is less than 5, so we need to change it to 5. So this is our final array. So guys, I hope you understood like how are we updating the array. Okay, whenever we get a query of type 1, whenever, see, there are queries of two types. Okay, there is query of type 1, there is query of type 2. If you get a query of type 2, na, update all numbers in array less than x equal to x. And when you get a query of type 2, you will be given I and v. It simply means update a of I equal to v. Okay, so guys, in total, let's say we have n queries, okay, or m queries. We know that they are 10 raised to 6. So let's say we have m queries, okay, m queries. So guys, doing this operation is very easy. You just need to set a of I equal to v. So this takes o of 1 time. But this operation, for this operation, we have to traverse the complete array, and then we know which are the elements less than x, and then we can update it with equal to x. Okay, so guys, this query will take o of n time, where n is the length of the array. So we are having m queries in total. If we try to check, we are having m queries. Okay, and the worst like the maximum time a single query which can take is o of n, because for query number 2 is easy, we can do it in o of 1. But what if only okay, query number 2 is easy, but what if all the queries are filled with query number 1 only? Query number 1 takes a lot of time, right? See, query number 1, you have to update all the numbers which are less than x by x. Okay, replace them by x. So this will take o of n time because you have to travel the full array, and traveling the full array takes o of n times because there are n elements in the array. It is just basic common sense. Okay, nothing special. So we have m queries. The query 1 takes o of 1 time, and
The query 2 takes O of n time. So let's just assume in the worst case all queries take O of n time, and there are m queries. So the total time complexity will be m into n. If you write this code in the TikTok way, you will pass some test cases, and then you should just pray that they call you for the interview. But most probably it will not happen because the competition is very high these days, especially in not what to say. So O of m into n is brute force. It will not work. Why? Because the value of m is also 10 raised to 6 and n is also 10 raised to 6. So if you multiply these two numbers, what you get is 10 raised to 12. Okay. So O of 10 raised to 12, it is very, very large. You know, na, in a competitive programming or online test, the maximum number of operations your code should be doing is 10 raised to 8 because it gets executed in 1 second. But O of m into n algorithm requires 10 raised to 12 operations, which is just way too much, much greater than 10 raised to 8. So it will take way too much time compared to 1 second, 2 second, whatever. So this is clearly not optimal. So let's try to discuss some optimal solution to this. So, guys, while solving these type of questions, now we should really focus upon our observational skills. So, okay, so guys, what would happen if you do only operation two? Let's think about it. What was the operation two? Operation two is given an index I and value v, modify nums I to v. So, if just assume that we had so many queries, let's just assume we had many queries. Okay, and say we have query 1 2 3 till 10, say. Okay, each query is of type 2 where you have to update a of I equal to v. This is also of type 2 where you have to update a of, say, g equal to b. So guys, doing this is very easy. In the array you can directly write this statement and your job is done in O of 1. Okay, so guys, if all the queries were of type 2, there would be no issue. Now the second observation which I want you guys to do is what would happen if all the queries were only of operation 1, guys. This is the way we try to break down the problem. Whenever the question is telling you now that try to do like minimize this or give the answer by doing one operation 1 and operation 2, always try to think how would you solve the problem by just doing one operation. Do them separately, then try to combine them, then the problem becomes actually easy. Okay, so let's say we had only operation number 2. Okay, operation number 2. So say the first query says that you have to make all the numbers like the first query the value of x is 5. For the second query of type 2, just a second, yeah. So for the second query of type 2, say this is 6, say this is 8, and say this is 3. Okay, so say you are given an array, you are given a very large array, okay? And what is the first query saying? First query saying is that whichever numbers are less than 5, just update them to 5, okay? So let's say you had 1, 2, 3, 4, 5, 6, 7, 8. This was your array. Whichever numbers are less than 5, update them to 5. So I make this also 5, this also 5, this also 5, this also 5. 6 means whichever numbers are less than 6, update them to 6 in the current array. So this also 6, this also 6, 6, 6, 6. 8. It means like whichever elements, let's say we had 9 and 10 also. Whichever elements in the array which are less than 8, update them to 8. So make this 8, 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 this 8. You guys can see that all the array elements become equal to the larger number. Okay, this is the first observation. What is the last query? The last query is saying that whichever number is less than 3, update that to 3. So there is no number less than 3, so this query doesn't, like, you have to this, if you execute this query, nothing will happen to the array. So guys, there is one very crucial observation from this thing which we are trying to do. Okay, let me explain it in an easier manner. The observation is that only the largest number matters in all the queries. Okay, the other numbers don't matter at all. Say the first number is you have to make all the numbers less than 5 equal to 5. So you do that, then just a second, guys. So say we had a 5 year, okay, then we had a 3 year, okay, then we had a 8 year, okay, and then we had a say 2 year, okay. So guys, my conclusion is that all these operations don't matter. Only the largest number matters. What I mean to say is you only check the largest number. Say largest number is 8. So the final array, in the final array, what will happen? In the final array, nothing special will happen, but all the number which are less than 8 will be replaced to 8. This is my conclusion. Now, how do I reach to this conclusion? I will explain you. Let me increase this. Let's take a random array. Okay, let me take a random array. Okay, so guys, I just want to say that if my operations were like this, that the first operation was query 2, all are query 2, but for this one the number is 5, for the next one the number is 3, then 8, and then 2. So my conclusion is that all these numbers don't matter, only the largest number matters. Okay, the largest number means that I am saying that we have so many numbers, but I should only perform this operation and completely ignore all the other operations, and the effect remains the same. So say you are given 5382. Okay, 5382. So 5382 are all are our operations, and let me write some random array. 1 1 2 2 3 4 5 6 7 8 9 10. So guys, if you observe carefully, when you do the first operation, you have to make all the numbers less than 5 equal to 5, right? So you will make all these numbers 5, right? All these numbers you will make it equal to 5, right? So 1 2 3. Okay, 1 2 3 4 5 6. So you will add 6 numbers, all these become 5. Then whenever a smaller number comes, now it doesn't matter, because you have already made all the numbers less than equal to 5. So obviously there will be no number less than 5 in the array currently, so this 3 doesn't matter. Only when a larger number comes, na, then we are supposed to do the operation. Now it's saying whatever numbers are less than 8, make them equal to 8. That's why I was saying that only the largest number matters. I hope you guys got why what I was trying to explain. Now the second operation is saying that whichever numbers are less than 8, make them equal to 8. So make all 8. Okay, this also 8. Now you guys, can you guys just observe that now you have made all the values less than 8 equal to 8. So if now any operation comes which has having value less than 8, say some guy now comes and tell you make all guys less than 2 equal to 2, make all guys less than 5 equal to 5, nothing will happen. Why? Because the guys don't even exist. Now you have made all the less than 8 equal to guys equal to 8. So the lower numbers doesn't matter, only the highest number matters. So what I was saying is that even if you completely ignore, now see, this operation will not work. Even if you completely ignored everything and just made worked on this operation, is that making less than equal to 8, even then the final array would look like this only. So the observation is pretty much clear. If you do this, then the solution is like in O of 1s, easy. In this operation 1, if we only keep on doing operation 1 now, we just need to perform the operation of largest number of x and ignore all other operations. This is a very nice problem based on observation methods. Okay, so back in my time I used to love problems like this. I still do, but I don't get so much time for them. So now let's try to see, can we mix the operation 1 and 2 and reach some stronger conclusions. So guys, now the things are really easy. Okay, they are not that hard. Like, this problem is really daunting at first if you don't make these operations. Okay, now guys, what if we have operations 1 and 2 at the same time? Okay, so you guys, first thing I want to make clear is that the each index for different indexes the things go different. So what happened when you say that operation 1, like, wait, let me check which operation is which one. Yeah, when you say for that operation 2, a of 5 equal to 8, and say the next operation 2 is a of 8 equal to 3, so these are totally independent. What is happening on index 5 has no meaning with index 8, so always remember that thing. Okay, so I hope guys this much is clear. So now what I want to say is, let's say we have an update operation, and we have operation 1 and operation 2 like at the same time. So say I have an update operation here. Okay, means less than x operation here. I have a less than x operation here as well. I have a less than x operation here as well. Okay. And in the between, I have an update, normal update operation of a of I equal to v. Okay. So guys, my simple trick is that suppose you have an array. Okay. Suppose you have an array and this operation is coming where they are saying that update a of I equal to v. So just like a good person, what you do is you update a of I equal to v. Okay. Now guys, just to mix up all these operations, you know what is the easy thing you can do? You just need to check what is the largest x which is coming in the rest of the part which is left in the suffix of the array, because once you update it ai equal to v, so it means that this number is now equal to v. Okay, this will only get affected if a operation comes which says that update all the numbers less than x equal to x and v is less than equal to v is less than x. For example, say a person comes and tell you that update a of I equal to 5. Okay, so you write it as 5. Then comes an operation which says that update all the elements less than x equal to x, and let's say the x is 3. So update all the numbers less than equal to 3 to 3. This will not change this number. Okay, we're just trying to focus and catch up on what will change which number. So if any, now if v was 5, now if there are x operations which are having values like 5, 3, 2, 1, 4, they don't matter. Only when a x comes whose value is greater than 5, say x comes as 8. 8 means what? 8 means update all the values in the array which are less than 8 equal to 8. So now you will have to update this a of I which you did 5, you have to change it to 8. Okay. So basically what I'm saying is that for each index I, whenever an update operation comes, say here we are having an update operation a of I equal to 5, and here we are having less than x operation, less than x, less than x operation, less than x operation, and less than x operation. Here they are saying 3 less than, and here they are saying say 50, and here they are saying 8. Okay, so if you are changing the index a of I equal to 5, means somewhere in the array there is a number at index I and you have changed it to 5. Just imagine the future. What will happen in the future? Obviously, as I taught according to the theorem 1, conclusion 1, only the maximum number of x value will affect the 5. So less than 3 will not affect 5 at all. 50 will change the 5 to 50, then 8 will again not change. So only focus on the maximum number which is remaining in the leftover suffix of the array. The last part of the array we call it as the suffix of the array. So guys, this thing is really important. Okay, yeah. Cut me some slack, let me drink some water. So guys, my second observation is that uh, for each operation of type 2, which is a of I equal to v, you only need to consider a maximum of all future less than x update type 1 operations. And guys, one more observation is there, that only consider the operation 2 for last index. What I mean to say is that you don't need to consider all the indices. That's why we'll be traversing the array from the end. Means, say you have a query where first query is a of 5 equal to 8. Then there are some, this is the query of type, I think I just forget the type sometimes. Okay, this is the query of type 2. Then there are so many queries of type 1, just assume. Then again a query of type 2 comes and the index is also same, a of 5 equal to 10. Then again some queries of type 1. Then again a query of type 2 comes which says a of 5 equal to 2 equal to 5. Okay, so guys, my point of matter is that you should ignore all these queries. You should only consider the query of, here the I was 5, the index was 5. Okay, right? So out of all those three queries, you should only consider the last one. It is common sense actually, because this number is constantly changing. So you should only see what is happening in the last, right? Because you have to print the final array, right? Sometimes they are saying that a of 5 is 8, right? Then they are saying a of 5 is 10, right? Then they are saying a of 5 is 5, right? So 8 and 10 doesn't make sense because these values got overwritten, right? So see guys, these are the things which LinkedIn influencer or YouTube influencer will teach you. All they will teach you is those simple, easy, popular coding interview problems. No one tries to help students for these hard online assessment problems. Only I am in the space who is trying to do that. So guys, make sure you like and subscribe and support the channel. Okay, and I want each one of you to become successful in life and get a great job. So, and get good coding skills as well. So guys, the thing is, my last observation is that for each operation of type 2, you should consider the index which is occurring at the end only. The initial a of 5 doesn't matter at all. Okay, so the second of observation I'm writing, I will like mention the link to code, question, observation, this document, everything in the description. Guys, don't need to worry about anything. So the second observation was only consider the operation 2 for last index. For the index occurring the last time in query. So if the same index is occurring again and again in the query, then you should only consider the index which is occurring for the last time in that, in all those queries. Okay, so this thing is very much important. So guys, the general problem we have completely solved it. This was a very hard problem and it requires so many conclusions. The time complexity will be O of n plus q, because all you are doing is just traveling the array and traveling the queries and getting your job done. How will you solve this problem? uh, this is your query array. Okay, you have query 1, query 2, query 3, query 4 till query m. Okay, so you should travel from the end. Okay, first you come here, you check if it is you just check if it is query of type 1 or query of type 2. If it is query of type 1, say it is query of type 1, query of type 1, query of type 1, then comes query of type 2. So whenever there is a query of type 1, just ignore it, don't do anything, just note down its x value. Say it is xi, it is xj, it is xk. Just note down xi, xj, xk, and then take the maximum of all these values. Okay, just take the maximum of all these values, because this is very important. Then when a of I equal to v query comes, a of I equal to v query comes, all you need to do is just write a of I equal to v, but be a little bit smarter. Be a little bit smarter. Replace v by the maximum of what you got in xi, xj, xk. Why? Because only these three, because only these three, the maximum of these three values will only affect our answer, right? It will change it because we studied. So by traveling the array from the backward side, we can always maintain the maximum of x values of type 1, and we can easily write, whenever type 2 operation comes, write a of I equal to v, but don't stop at v. Compare v with the maximum of all the previous x values, then write the final answer. Okay, so a of I should always be equal to max of v comma mv, where mv is nothing but the maximum of xi, xj, xk, whatever the suffix values were there. So guys, the problem is not totally completed. Let's walk through the walkthrough of code, and then we can end the video. Thanks for joining. So guys, it's nothing, we just take the array, take the input. Okay, as simple as that. Now we have a queries, we are reading the queries. The language doesn't matter, C++ or Java or Python, because all we are doing is making 1D arrays, 2D arrays, and running some for loops. That's it. No rocket science. And Python, guys, instead of map, you guys can use dictionary. Okay. So here you are taking the input of all the queries. Nice. Very nice. Now you see, guys, the thing is we start traversing the array from backwards. Okay. We start traversing the array from backwards. So I start traversing the array from backwards and check. If the query is of type 1, I do nothing. I just update VV equal to WI2. WI2 is nothing but the query value with the max of VV, which I explained just now here. Okay. That A of I equal to max of V comma MV. So that's why this, okay. Yeah. Okay. So if W of I of 1, it means the type of query. If we are having the query of type 2, what is the meaning of type 2 query? Means we just need to update A of I equal to V. So I could write G. So we write G of Y equal to WI3. WI3 is nothing but holding the value of V. Okay. So G of Y equal to V I wrote, but I still need to compare it with the maximum. Okay. The maximum suffix value. So VV is nothing but keeps track of maximum suffix value of operation of type 1 or less than x. Okay, for less than operation, whatever. Okay, so this is completed. And also, because we have used this index already, we are adding it to our map, so we don't use it again, because if the index comes again, we will not be using it. Okay, guys, make sure you guys remember this thing. Why not to use the index again and again? Because I clearly explained here that if A of I 5 is coming again and again, A of I is 8, A of I is 10, you only consider last index. So when it is coming, I am traveling from last to top, right? So if 5 comes for the first time, I will add it in my KK map. Okay, but then when it comes for the next time, I will do nothing. I will just ignore these numbers. Only the last time it comes, it matters. Okay, these are the some commonsensical things which, if you have a nice practice, you can obviously do. So the thing is, this is how I complete. Then afterwards, in the G of I store all the perfect answers. Okay. So I have initialized the full G of I with -1. So whenever there is a -1, I will think what to do, or else I already know what to do because I have written the values of G of I. So in case it is -1, all you need to do is replace G of I by B of I. But make sure if B of I is less than VV, VV is nothing but maximum of this full array. Na? You guys learned now that only the maximum value matters. So once you are done updating all the values with the help of operation 2, okay, once you have like solved the question for operation 2, the operation 1 thing is very easy. Okay, because only A of I equal to V, like these things are very commonsensical now, but I can understand that the beginners will not understand. That's why I am trying to explain it in such depths. Okay, so the thing is that this is the last explanation. Let me give it. So the thing is that, say you are done updating. Okay, say you had queries like this: query of type 2, type 2, type 1, 2, 1, 2, 1, 2. Okay, and A of I equal to V. Okay, so this query was saying change A of 5 equal to something. Then this query was saying A of 8 to something. This query was saying A of 2 to something. This query was saying A of 9 to something. This query was saying A of 100 to something. Okay, you did all these values. You know now what should be the best answer, considering the query 1 also in the mixture. Now all that is done, but you don't know what will be the value of A of 1, A of 3, whichever is not included, you don't know, right? So I am calling all them as G. Okay, G of 1, G of 3, whatever. And as I filled everything with -1, so these values are filled. So these will not be -1, but these will be -1. So whichever values are not filled, I have initiated them to -1 and then I fill them. I replace them by the original array values and also make sure if I know the maximum. Maximum, because all the values will be updated by the maximum. You guys know this fact, okay? You guys know this fact that if I have many queries like 3, 8, 2, 80, and 5, if you have so many update queries of less than x, you know guys what happens? Nothing matters. This all these queries, nothing matters, only this query matter. And I've given the explanation. So whichever indices are not filled, you can directly apply this rule on them. If they are less than 80, just update them to 80, or just chill out and your life is done. So by this you can solve the TikTok way, pass the interview, and get a good package for software engineer. Enjoy in your life. So I am now stopping the recording. Let me see where it has gone, man. Okay, yeah. So thank you guys for the make sure guys you like and subscribe.